Hello and welcome to the channel. Today we'll explore two fundamental network models, OSI and TCP/IP, not just from theoretical perspectives, but in terms of how they influence the way we troubleshoot, configure, and work with real networks. Understanding these models helps you locate problems quickly and fix them efficiently. Before we proceed, if you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. So, let's start with the OSI model. The OSI model, or Open Systems Interconnection Model, is a conceptual framework that describes how systems communicate over a network. It's divided into 7 layers, from the lowest level physical layer to the top level application layer. Each layer performs specific functions and communicates with the layer directly above and below it. The first layer is the physical layer. It defines the hardware level transmission of raw bit streams. This includes the electrical signals, pin layouts, voltages, optical levels, and other physical specifications like Ethernet cables, fiber optics, and wireless frequencies. It doesn't understand protocols or packet structure. It's purely about signal transmissions. Next is the data link layer. It's responsible for node-to-node communication, framing, and error detection. It packages raw bits from physical layer into frames and ensures they are transferred without error. MAC addressing, switch operations, and CRC checks happen here. Above one, that is the network layer. It deals with logical addressing and routing. This is where IP addressing lives. Routers operate here, forwarding packets based on destination IP addresses. It figures out how to move packets across multiple networks to reach the destination. Then we have the transport layer. Its main role is end-to-end communication. It ensures that the data segments are delivered completely, in order, and without duplication. This is where protocols like TCP and UDP operate. TCP provides a reliable connection-oriented transmission, and UDP provides faster connection-less communication without guarantees. The session layer sits above the transport layer. It manages sessions between applications. It handles connection setup, maintenance, and teardown. Functions like authentication and session restoration are handled here. Although in modern stacks, much of this is handled at the application level. Next comes the presentation layer. This layer ensures that data exchanged between systems is in format both sides understand. It handles translation, encryption, decryption, and compression. While it's often invisible for developers, it's critical in cases where data formats differ between systems. Finally, we have the application layer. This is the layer closest to the user or to the application that needs network access. It defines protocols like HTTP, FTP, SMTP, DNS, etc. This is where browsers, email clients, and APIs operate. Now, let's shift to the TCP/IP model, which is more practical and implementation focused. Unlike OSI 7 layers, TCP/IP uses only 4 layers: link, internet, transport, and application. The link layer combines OSI physical and data link layers. It handles direct communication with the hardware and includes Ethernet, Wi-Fi, and device drivers. The internet layer maps the OSI network layer. It includes the IP protocol and handles routing and logical addressing across whole network. The transport layer aligns with OSI transport layer. TCP and UDP are still key here, managing communication between processes across hosts. Finally, the application layer in TCP/IP, same OSI session, presentation, and application layers. It handles data formatting, encryption, session control, and the user-facing protocol. The TCP/IP model is older than the OSI model and was designed to solve real-world networking challenges, not just to define structure. That's why it's simpler and more widely used in practice. Most of the internet today runs on TCP/IP. It's important to understand how these models relate. For example, when a web page fails to load, you may troubleshoot from the application layer downward, checking DNS resolution, then routing, and eventually hardware or cables. This top-down or bottom-up approach follows the layered structure of these models. And in interviews, for example, you are often asked to explain how you'd troubleshoot based on these layers. From a practical standpoint, the OSI model gives you a clean, detailed view of how network communication works. It's protocol independent and useful for documentation and trainings. TCP/IP gives you a bit more streamlined, protocol-oriented view used in most modern systems. Both are available. Understanding them helps you think more clearly about where problems might occur and how data flows through complex systems. Thank you for watching and see you next time.